Hello, I'm David from David Savory Electrical. Now, as we go into 2018, I bet you're thinking 18th edition is what this year's big buzz is all going to be about. But no, I've got a game changer gadget here that I've been playing with, and for anybody who performs electrical installation condition reports, this fella is about to make your life a whole lot easier. It's been a frustrating few months as I've been wanting to upload this video since Christmas, hence the funny hat and jumper in the introduction. So what on earth is this thing, you may well ask? Well, it is an electrical analyst probe, and I've been playing with the engineering prototype, albeit not the market release version, which I'm told will look a little different to what we see here. This product is so new that its name was only released on the manufacturer's Twitter account just a couple of weeks back. The manufacturer, Schurz Electric, if that's not a mispronunciation, asked me to put this thing through its paces some time ago, but they subsequently asked me not to publicise anything until their Easter 2018 release date. However, today is the 1st of April, Easter is officially upon us, and if you're a Sparky who performs electrical installation condition reporting, then prepare to have your socks knocked off. But what does it do, I hear you cry? Well, it's going to perform many of your EICR tests for you without you having to disconnect the circuits in the consumer unit or break out your multifunction tester, as I will now quickly demonstrate. It's the size of a standard MCB, and the manufacturer claims it'll fit into 93% of 16th edition or later consumer units. With the power off, connect it to a spare way on the buzz bar and hook up the neutral and earth fly leads. Next, open the app on your Windows laptop. Apparently an iOS port is in the making for those armed with iPads instead of laptops. This is a beta version and it lacks a little polish. There's even the odd spelling mistake in there, but I presume the launch version will address such issues. Once in the app, use the handy drop-downs to tell the software how the distribution board you're testing is physically laid out. Select what protective devices are in use and the size and type of wiring utilised for each circuit. Once all the information has been entered, the start button is no longer greyed out and we can commence with the fun part. Now plug the supplied USB cable between the laptop and the device. It's USB powered, so no need to make the buzz bar live. Click the start button to commence the dead testing operation, where it will open up a basic graphical representation of the distribution board you're looking at. And here are the test results landing in real time as the probe pulls the circuits, but don't worry about missing it as I have a capture device in my laptop's video port. Here, the analyzer probe is determining the R1 plus R2 impedances by sending a ping signal down each circuit and measuring the time it takes for that signal to reflect back from the circuit endpoint. The longer it takes, the longer the circuit, or the poorer its connections, and the higher the returned impedance. The app divides the result by the known resistance per metre for the stated cross-sectional area of the wire to calculate the circuit length. It's able to test each circuit at the same time and without any physical disconnection of the wiring in the consumer unit by using frequency separation of its own internally generated low voltage AC carrier wave. So the ping pulse on fuseway 1 is at a different frequency from the pulse on fuseway 2 and so on, with up to 25 fuseways being supported. Although all circuits are tested simultaneously, the higher the impedance, the longer the result takes to be returned, it seems, but it's only fractions of a second and that one button click returns all your R1 plus R2 results almost immediately. The anal probe can detect ring circuits, as it has here, and it can send the ping pulse down each leg. Cleverly, the ring wiring doesn't need disconnecting for this, as the device uses biasmic harmonics to effectively pulse both wires in each of the line, neutral and earth legs for the ring circuit, with one leg being cancelled out with respect to the other to allow a full end-to-end test. Now, I'd love to pretend I know all about biasmic harmonics and their effect on AC waveform propagation, but even after reading the Wikipedia page 5 times, I confess I still remain ignorant of the technique, so I'll leave it to any physics boffins who may be watching to explain how that works in the comments. Here, I've disconnected the neutral in my ring circuit to simulate a break. If there is a break in the ring, then the ping pulses will be reflected back down each leg from the break point, thus giving you an indication of how far away the break is and where you need to be concentrating your fault finding efforts, which I'm sure I don't need to tell you is an absolute boon. The anal probe can perform an IR test at 250 or 500 volts thanks to a micro step-up coil built into it. Results come back in it up to 99 megaohm, which is a lower full-scale deflection than most IR testers on the market, but plenty high enough to satisfy regulatory testing requirements. It auto shorts line to neutral internally, so cannot IR test between live conductors, but it does test both live conductors of each circuit with respect to earth. Again, frequency separated probing allows it to test each circuit individually but simultaneously without disconnecting any wiring. Once the dead testing is complete, the consumer unit can be powered on with the device still installed in order for it to perform the RCD testing. The device will perform half times, 1 times and 5 times tests for 10 and 30 mA RCDs, and also supports 1 times testing of 100 mA RCDs, including time delayed variants. The manufacturer tells me that the market release version also supports ramp testing in the software, but the beta version I have here lacks this and I cannot demonstrate that functionality today. Magical though it is, it doesn't do everything. Live ZS, ZE and PFC tests still have to be undertaken, as well as visual inspections, bonding verification, mechanical operation, suitability of equipment and so on. But the Scher's electrical anal probe gives rapid results for the most common tests with no need to dismantle the circuits at the consumer unit. At €840, the price is comparable to a replacement multifunctional tester, but the time savings on testing will be huge. Those performing regular EICRs will immediately recognise the value for money. For those technophobe electricians out there, I'd like to say that unlike many other gadgets which are supposed to make life easier, technology like this actually does. So it's time to embrace the new ways, and this April 1st I urge you all to whip open your web browser and ask Google to tell you all about the new electrical anal probe on the market.